All right. Hello, hello, hello. Checking some levels. I think the mic's good. Good, good, good. Let me just adjust a little bit. Check all the stuff. All right. Welcome back. Another week of hacking on whatever Haskell stuff, things, wave function collapse, all that kind of stuff. We're gonna learn. We're gonna write some code. We're gonna figure things out. And yeah, hopefully have some fun. If it's your first time tuning in, welcome. I'm Agent Doldra. I hack in Haskell on various projects to show the people that you can make real software with functional programming and Haskell in particular. And we're learning about wave function collapse. So wave function collapse, if you don't know, is a procedural generation algorithm often used in, well, I guess a lot of games probably use it. It's really popular. So people use it for generating random levels or textures and things like that. And well, let's just dig into the code. Let's just go. All right. Bam, 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 bam. Kind of got everything in one big, huge, giant file. And that's all right. That's how we do. Let's get our builder going. Let's use the test runner. Their builder with the fast option and file watch. Turn on the file watcher there. Okay. Handy dandy water. Gotta stay hydrated. Okay, so last week we were working on the collapsing part, so elimination. So when we're eliminating a pattern from a cell, we've chosen a value for it, and we need to eliminate all the other possible values from that cell that we've chosen a value for. And in so doing, by eliminating or removing a pattern from a cell, there may be other cells that are adjacent to it for which we can no longer pick a valid neighbor for it, like a neighbor pattern. So we have to remove those as well. We might as well kind of push this forward and eliminate those as we go along across the whole grid. This is why I kind of classify this algorithm as a forward constraint propagation solver, if that makes sense. Something happened to my music. Maybe something happened to my internet. Let me just double check, yeah. Things are good there. Okay. Something's going on with the music. I don't know what, though. Hopefully it'll come back. Anyways, yeah, forward constraint propagation solver. All right, so we're pushing, every time we eliminate a variable, we got to push that out. So, eliminating, we got to get the neighbor removals. So these are the neighbors, the one we just eliminated a value from. We're going to all the neighbors in all the different directions, and we're picking out the ones we can't place anymore. And so by getting those removals, we are pushing them onto the stack. Push removals. All right. We push a list of removals that we want to remove onto a stack. We have to implement that. And modify cell at looks like. Okay, so let's go ahead and do this. Give it a pattern, name, removals, do, and a little hole there. Jump over to wave state. Wave state, yeah, there we go. And our stack here is the remove pattern stack. Okay. Just want to make sure it says I'm live. If anybody's in chat, just let me know that you're there. think it's still connected. Yeah, okay, it's just pretzel. I don't know. Okay. So yeah, we just want to push those and consoles onto this list here. And then I think the last thing we actually have to do there is we have to update the entropy of the remaining values, the entropy of the cell. We also have to do that before we're done with elimination. Let's go over there. Let's see. So when we want to push on there, we're going to modify the state. There's a modify function for that. Yeah, modify strict. Yeah, we're going to do the function, so as such that wave state removal, wave states, yeah, removal list. Oh, I have the memory of a fish sometimes. Yeah. That's not it. Okay, it's called Stream Brain. So that's my excuse. Don't normally talk when I code, so bound to get a little distracted every now and again, and that's okay. Jump. Pop, pattern stack, that's the one. Okay, so we want the wave state remove pattern stack, and we want the removals added to that. Kind of ugly, huh? But I think that'll cover it. Yeah. Okay. I wish for me some lenses. Starting to get to that level. Okay, so let's just bring this over a little bit so it's not quite so inky, going off so far over to the right edge of the screen. Do that one here later too as well. Coo. Okay. All right, so that pushes the removals onto the stack. So now the algorithm can proceed to remove off of that stack and eliminate. Right, propagate pops off the remove stack, calls eliminate to remove the pattern we just popped off. Eliminate goes and modifies the cell there to remove it from that pattern from that cell. And then we get the neighbor removals by looking at all the neighbors in each of the directions. Get the neighbors we're going to want to remove from those cells, push those on. Okay, last thing we need to do is update the cell, the cached entropy data in the cell. All right, so remember way back when we implemented this. Is it in the cell or is it in? Yeah, these two values here. So the cell total weight and the sum weight of weight log weight. So we have this fancy function for picking which cell to collapse next. The idea being that with a good function for this, we're going to encounter hopefully fewer possible places where the algorithm will get stuck. Right? Contradiction, I think is what we call it. We cache that here instead of calculating it for every cell when we do an update so that because we use it fairly frequently, it's not recalculated for the whole grid every single time. So we just have to update it for this cell. I think we have a function for that already. To jog my memory what it was called. Check cell collapsed, total possible tile frequency, weight, sum of weight. That's how we calculate the sum of weight, log weight. That's how we get the entropy of a cell using those values. Okay, so total possible, check the collapsed, remove possibility. Oh, we have a function for that. I think we might have duplicated the functionality. Yes, there's recalculate total weight and sum of weight, a lot of weight. Oh, okay, we already do. Okay. Okay, so this removes the possibility from it, recalculating those things. Okay. That's what we need to do. We need to use this. I've got to remember to check our notes. Okay, let's jump back over to eliminate. Let's get neighbor removals, eliminate here. Yes. So we do that elimination here, the same one that we do in remove pattern. And we need to remove possibility. Yeah. So we do that same pattern here. Cell possibilities, pattern, false. Do that same update. Cool. Okay, so we need the frequency hints for this one. The pattern index we want to remove, the cell itself. And we either get a string, possibly an error string, I guess, or a cell. I'm going to comment that out. We're going to get a value back from doing this modification pattern. I'll remove possibility. We have to get that adjacency map out, or the map thing that it needs. I guess is the pattern index and the cell itself. So we need to get the cell. Done the get cell at. That takes something. And we put cell in here. If we case match on that, we get left something there, and then we get right on the new cell. Right, and all we want to do with the updated cell is put that back into the state. Modify cell at. We haven't implemented that yet. Ooh, that's a pretty nice little type signature. Select is the location of the cell we want to update in the grid. If we just change the function of this to be our or we pass it a function that fits this shape, then we should be able to use modify cell at, do all that work. Right, so we have a location we want to put in there and a function. Okay. Now, the function that we give here, remove possibility, that's not cell to cell. Cell to either string cell. We could change the type of this to be cell to cell, perhaps. I don't know where we use the left here. Check collapsed might be. We do it here. We check for collapsed. So we could. See chat. Make sure you're here. Boop. Boop, boop, boop. Okay, I got the music back. Skadoosh. Okay, so we have to propagate this either. We have to handle it, basically, is what I'm getting at here. And eliminate. Or modify cell add. Yeah, sorry. Music just doesn't want to go tonight. Doesn't want to go bare. We go either string cell like that. That would fit the shape that we want. All right, but then, what do we do with the state here? In the left case. All right, we just have state. We could throw like an acceptee over a state and have it like a transformer stack for this, but I want to keep it nice and simple. Oh, welcome back, Happy Beach. How's it hanging? We're having technical issues with the music tonight, but otherwise going strong. Well, hello, one viewer. Welcome. You're in good hands. Or not. Maybe you've come to the wrong place. Anyways. Yeah, so I have to either handle that either somewhere. So maybe... Well, thank you. Thank you. You have a good one as well, whatever you're doing. We'll see you soon, Happy Beach. So maybe we could put the left value inside wave state. Or we could just throw a runtime IO exception. You know, we're just learning here. It doesn't have to be perfect. That's what I'll do. So if we get a left, we'll just throw an error. That. We'll throw with your string. Okay, so modify cell at, then we get the index, cell index, and we get the user's function. Yeah, call it that, I guess. All right, so we got to give the cell as input. So we have get cell at x. Okay, and then we're going to cell x, sorry. Then after we get the cell, we're going to call the user's function. We're going to case match on that. We get the left error. Just error the error. Super great. Otherwise, you got to write, and that's the new updated cell that they modified that they want us to put back into that place. So do I have a corresponding put cell at? I don't. Okay, so that's what I want. I want a put cell at function. Cell X with the updated cell. We'll call it cell. Actually, that shadows the name, so I'll call it cell prime. Change cell. Okay. So I'll do put cell at, excuse me, int cell and wave state cell. No problem. There we go. Funky door. Happy, dandy. Put cell at. We just have to implement that. Cell index, the cell that we want to put. Modify there. This is going to be pretty straightforward. Hopefully. Modify. All right. So here we get an S. We're going to do something with that S. And that's what we got to figure out. Okay, so jump over to wave state. We got the grid. Grid might have that stuff. Grid cell there. Okay. No, I don't have a helper function for that either. This is totally new stuff. All right. So our grid is just an array, a two-dimensional array. All right, so we know the update syntax for that. Well, if I'm writing the same code over and over again, aren't I? All right, so here we go with our array on the left. So I'm going to get cells of grid. We're going to use array update // and we have to give it the association list of the things we want to update. So cell X, and we need to pull in the cell. The tuple. That should be hunky-dory. And then we go here, and we go set S such that wave state grid equals set cell at cell X cell with S dot wave state grid. Okay, and we have a type could match the type unit with cell. Oh yes, that's a unit, isn't it? Good, 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 good. Okay, we're back there. Okay, so we have a few holes here to do. So call modify cell at with our cell index from the remove pattern. Propagate cell x, that's the one. And propagate cell pattern x. I don't think we need to touch that field. Okay, we have that in scope because we were using the record wildcard here. So we bring in a scope like that, and then this hole here is our function, remove possibility. And remove possibility takes some parameters. It needs the frequency hints, the pattern to remove. And then we're good. Bring that over a little bit. Okay. Okay. All right, so the frequency hints, I think we can get those from the wave state, if I remember correctly. Got frequency hints. Grab that. Spot again. We are. Yeah, pull it in. Freak hints. The freakiest of hints. Then we just need the pattern index we want to remove. That also comes from the pattern. Propagate cell pattern index, I think. Yeah, good, good. Okay, so there was an... in the left case here, we'll have to deal with that in a minute. We know what we want to fill in that hole, and the remove possibility. That one's a frequency hints. Ooh. Hang on a second. Oh, this isn't good. We don't remove possibility, I remove possibility. I think actually we could remove this. Bring that over. Pop that over there. Do that. Where's our other pattern here? Okay. We're expecting type grid with actual type array. Okay. What am I doing? Grid get cells. Yeah, grid dot get cells. Maybe try it this way. Oh, we got to return a grid. This returns an array. Yes. Derp. A derp, a derp, a derp, derp. We got to wrap it back up. Okay, we're back to compiling. Everybody's happy. Except for Pretzel. Pretzel just doesn't want to be happy. I'm going to take a moment to see if I can remedy the situation here. Okay. Try and fire it up with the web app. Okay. I think we might almost be there with the music. Okay. I think we're back now. Okay. So yeah, that's going. Okay. Okay. Cool. So let's review here quickly. Let's set cell. Well, we got some code in there that we commented out. We should probably remove here. Okay. Try again. Set cell. Okay. Remove possibility. Okay, and we call set cell down here. It appears put cell at. It's a fair bit of indirection to get that there. Okay, modify cell at. Okay, yep. All right, well, let's push that up. Or make a commit. Okay, implement. What do we implemented? Modify cell add, push removals. Cleared up a few things. Q. All right, so that is propagate. All right, let's review now. Oh, right. We gotta update the cell's entropy cache. Okay. So. Oh, that's already handled. That's handled by the remove possibility stuff. Yes. Sweet. Okay, so back to reviewing. Then we insert the cell into the heap list. Okay, yeah, so we update the cache, we have to put it back. So we pop it off the heap, we got to put it back into the heap now that it's updated. One little thing. Maybe we should do that remove possibility. We're updating all that other stuff too. No, we can't. That's a pure function. Almost a pure function. That is a pure function. Yeah. Okay, so what do we do there? That might have been. Let's see. We can pipe another little function on there to do that modification. Or we can make modify cell at handle it. That is in the state, so we could do that here. So modify cell at, if we're modifying the cell, we don't necessarily need to do this for all cell modifications, just for the ones where we update those fields. So we could ask the callback to tell us when they want us to do that here by telling the return type to like set a flag with the return. We could do the comparison ourselves with the input cell and the returned one, the updated one. And if those values, those particular fields have changed between them, then we can implement, yeah, that's probably the easier way to do it. Maybe a little bit sneakier way, but hopefully it'll be somewhat obvious. Okay.
Yet I do believe that the singularity is coming.
So when cell entropy changed. Then we also want to do the, put it in there. Into the heap. So we go where cell entropy changed. That's going to be a function from cell to bool. Right. And we'll go cell X and cell Y. Or we can do cell original, cell updated. I'm gonna use a little guard here. Actually, let's just pattern match these out. Maybe? Yeah. So we just want the last two. We want the weight X and log weight X. And log weight X. With cell weight Y, weight Y, and such that we have weight X equal to weight Y and log weight X equal to log weight Y. We know nothing has changed. Otherwise something has. We should put it in the heap. That's false. Otherwise true. Okay, so we're gonna put the cell in the heap. Do I have a whole pop function for that? Maybe add entry cell, put the cell, modify cell, push removals. Collapsing, propagate collapse, collapse wave, harmony. Okay, I have this little kind of helper function. We're building the entry replay list in the wave state initialization. Right, we used a little bit of the noise there. So what this function here is doing is that when we initialize the wave state, we're using like a min heap to keep track of the cell with the least entropy. Should be at the top. So when we pop off that min heap, then we get the cell with the least entropy there. So we have to do an insert. But when we're initializing it, we use a little bit of noise here so that because originally when you start the wave, they're all the same entropy. You haven't removed anything yet. So we add a little bit of randomness just so that the next one that gets picked is because they're all the same or similar. Or when you have ties, the values at the top of the min heap can be the same. So to eliminate the possibility, kind of like shake things up a little bit, we add just a little bit of randomness onto the key there. We need to do a similar thing for adding the cell back to the entropy list. Let's see, where should we put that? Maybe somewhere up there. Why not? Super organized. Okay, so let's do that here. Why not? Insert entropy into entropy list. That'll be cell, and we'll do a wave state. I'll do it like this. Why not? Okay, so in a similar fashion, we have to get our generator out in order to get a random number, right? Oh, added for cell. Oh, we do have a helper function for it. Okay, cell. Gets the entropy cells. Get some random noise. Entropy cells prime is the entropy cell. Inserted entropy cells. Okay, and then we modify state with that. Okay, that's what we wanted to do. Okay, so let's get rid of what we were about to do. Okay. Go back to our hole. So we don't actually, we just need to check if this changed, and then we can just, how do we sell here? Sell X. So that inserts it back into the heap with that little bit of randomness put back on it. Little randomness, pepper sauce, salty, whatever's, and then updates the heap, and then we're good to go. Okay, so I think we're pretty much, at least the core part of it, good to go. For each direction. Before we call propagate, I'll run wave. So this is just, so I think the core elements are there. We just need to tie everything together, and then we can start generating some stuff and trying this out. Of course, we'll also need some library helper functions to get from like an image format, load an image and stuff like that. And then to go from our array data back to like a texture format that we can then put on the screen. That sort of stuff. Okay, so run wave. Makes an initial wave state. Oh, state wave state a function. It returns a grid. Which doesn't really seem to do a whole lot here. Oh, right, because we have to give that in as the argument, that function. We'd probably give it collapse wave. So for some initialize output grid of cells while they're uncollapsed cells. Choose the cell with the lowest entropy, collapse it, picking a pattern from the possible ones that are allowed. Propagate that choice. Okay. So collapse wave is our main function here, really. It takes the remaining cells. When the remaining cells is greater than 0, we propagate collapse. Propagating the collapse, we choose a cell. Choose the cell with the lowest entropy. Collapse that cell at that index. And we propagate that choice out across the wave. But once we do that, then we call pure, which returns. So this will only propagate once. So we need a loop. So this should be this should be propagate the collapse and then call collapse wave again. Wait over time. Not so bad, not too bad. Okay, so this whole block will get run as long as this remains true. And then when there's no more to collapse, it's basically this returns pure unit within the state there. So then we go back up to run wave and we get the final state. And we get the grid out of that state, that final state. Okay. think that's pretty... Okay, so we don't need this here. Cool. Okay, let's do a little cleanup pass here. There's a lot of build errors and stuff. Okay, so we don't use that. Or that. I don't know if my builder caught that second one, so I'll just make sure force a rerun there. Okay. Another one here. Pattern matches are non-exhaustive. That's not good. Let's see. I think this one might be intentional. Okay, collapse at. I'm guessing it's going to collapse at a cell index, right? So we get the wave, a bunch of data of the wave state. We get the cells array out of the grid. And maybe at cell X. So we look for a cell potentially at this index. We get it, and then we collapse the cell. And construct a new grid. We'll probably clean this up with some of our modification stuff that we did. Anyways, then we get the new grid. Constructed such that the cell index and it's set to collapsed cell. And then this. Ah, okay, yeah. Collapse cell collapse. Right. Coming back to me now. So this is, I think I might have mentioned this on a previous stream a while ago. Ages ago, that I kind of wanted to maybe separate out the concept of a cell we're working on and one that's fully collapsed into two separate types. Because we have this annoying field, maybe pattern index. And I'm not a huge fan of having maybes in your fields. There are times where it's justified, usually when it literally doesn't matter if the data is there or not. It's like a convenience thing. However, this is formed as, this is like almost this field is almost named as a predicate and is used that way. Is it collapsed or not? And so my instinct there is to like have two different kinds, like a cell. It's either collapsed with its pattern index, or it's still working with cell data. That's kind of what I was thinking might work better. Then we'd have to like update a ton of code to introduce those two states. But that way, when you're pattern matching on the cell, then like you can pattern match on the cell and get collapse. Now this is two different types together. They're two constructors of the same type, so it wouldn't be that much of a hassle. But that way you don't have to check for the maybe there in order to get that pattern index out. It's just there in the collapsed branch. So that's why this is here. Because we just literally collapsed that cell. We just want the pattern that was collapsed to. Because we know that it's there. We just want to put it on the pattern, the root pattern stack. I think another way we could clean this up maybe would be for collapsed cell to return two things, the collapsed cell and the remove pattern. That could be a possibility. Let's try take a look at that maybe. Put some parentheses around there. Pop that over. Pop this over. Yeah. And then we need a remove pattern. We've got the pattern X here. And this index. We don't have the index. Or the cell location, basically. Well, we do have it up here. I might need to pass it down through, but maybe it's in scope here. Okay. Then we get that. We get rid of this whole line. And we can just make this the singleton pattern. That's what it looked like it was doing. Let's do here. That's interesting. I think what we were thinking here was that we wanted to do yeah, we wanted to initialize. Yeah, okay. So when we collapsed at for this cell, we wanted to get the neighbors that we also want to remove, like we do for, during elimination, and put this on the pattern stack here. Put those on the pattern stack. Now, this called in propagate. Here, then we go straight to propagate after collapsing at. And propagate. Pop off the remove stack. So in this case, it'll be just the one removal. Initially. Singleton list. We get the remove pattern. We go to eliminate it. And eliminate, I think we'll do all of that work, basically. We get the cell, add that. Get index. There's the frequency hints for the state. There's a modify cell add with the root possibility, which does all the updating of the cell state and stuff. Remove the possibility of that pattern index and cell. And then it does the neighbor removals here. For for each direction from the propagate cell index. That's the one we're removing. And that pattern that we're trying to remove. Yeah. And we push those onto the stack. So after calling that eliminate, then we stop. So we're missing a loop here. Just gotta call propagate again. And so we can propagate that. And we keep popping off the remove stack until we get to another case in which we return. And we go back. Propagate collapse. That's done. And we're finished here, and then we call collapse wave. Call this again. We got remaining cells. And the wave state remaining cells. And then we propagate collapse as well. Now this remaining cells, I don't know if that ever decreases. I don't think I saw it decrease in here, so we never may end up a place where this is false. Remaining cells, wave state remaining cells, propagate collapse. Choose a cell, collapse that. Propagate. We've got to check the remaining. Oh, we do update remaining cells. Here. Yeah, -1. Okay. Okay, so we just that's just a counter. We just decrement it once we've collapsed this cell. Okay. And I suppose we initialize remaining cells with the number of cells in the grid. Yeah, width times height. That's about right. Okay. Eventually that will be false, and that'll return unit, as we mentioned before. So then we finish collapsing the wave. And then, yeah, that'll be used by run wave, and that'll just return the final state to the user, the final grid. Okay. That's looking good. Couple more little warnings. So cell isn't used, that's not good. I guess we don't need that. We definitely don't need that. Wunderbar. Okay, and let's see. We had a couple of small things that aren't showing up the type checker here because of that thing. Okay, redundant constraint, wave state, EQ is not needed. A grid. Another redundant constraint. A grid. Okay, doesn't need the OR day there. Uninitialized fields and test spec, that's fine. We can fix those as well. No problem. Okay, let's just clean up the test spec code as well. Spec, there we go. Bang. On empty is no longer needed. And that one we know about, we're fine. Missing fields on line 69. Right, we added some things. Remaining cells, rules, patterns. No problem. We can fix those as well. Wave, I'll just add it at the end. Why not? Wave state. Remaining cells. I don't think it matters for this test, does it? I don't think so. And ooh, adjacency rules and remove patterns. And we'll put there. The other one's easy. Remove pattern stack. Where are we gonna get the adjacency rules? We just use empty ones. There we go. Fine with that one. Oh, we did it again. Shouldn't be. Maybe I'm just reading the wrong one. Yeah. Yeah, must be way off here. Yeah, it looks like it built clean. Okay. With just the fill pattern. That's fine. Okay, cool. Nice. This commit's just kind of some cleanup stuff. We'll commit those. This commit, when applied, will missing loops and clean up build. Cool. Alrighty. All right, that's that thing. All right, let's see if for a very simple setup, it just terminates really quickly and just ends up with a different state than what we initialized it with. It's just kind of like a lightweight check that things are kind of working. It might not be right based on like what we want, but we ought to be able to visualize the output really, I think, to be able to see that well. So let's just add a little example test case up here. It runs and changes the and Returns a grid. Different, changed from what we started with. Just a really basic example. I think one of the things I've been kind of hoping to be able to do with this is, like, I'm writing this, like, not the most efficient way that you could, probably. So I kind of want this to be, I'm hoping this will be as correct as possible. Like, we've specified it well enough that it'll come out well, and that we can use this as, like, our testing article for, like, a more efficient implementation. Hoping that's what we get. Now, what's the problem here? Yeah, I'm sure it'll be fine. Okay. So, let's go to wave function collapse here. And hopefully in writing this example, we'll get to see how the code will look using it. And it might give me some ideas on how to make the API a little bit nicer. And sort of tie things together a little better. So in order to get the patterns, we got to generate, we got to take those out of a texture, an input texture. Right, and then we call this patterns function, we get a pattern result, which gives us a bunch of our data that we need to run the algorithm with. Maybe what we can do is construct such a pattern from a list, maybe an input list. So if I had such a function, my input texture would look like this. Probably be a pure function. Alright. Let's kind of come up with a funky texture. Actually, we might be able to somewhat come up with something here that might be able to visualize things a bit. Let's go to the wave function collapse main Wikipedia page, or Wikipedia, GitHub. That was the gridbugs one. That's probably fine. This is a simple-ish enough texture that we should generate something like this from this 4x4 input image. Alright. And if it's just zeros and ones, we should kind of be able to see it printed out right, you know? Alright. Let's go with it. So that's 5 by 5, like this. Do a 1 here, 0 there. And the next row is all ones. And this one is a 0, 1, and 0, 0. Cool. Our pattern results. There's patterns on our input texture. Our sub-pattern size. Let's go 3, just like the example here. Okay. And then, once we have our pattern results, think we call make grid, make wave state. That's our pattern result. A seed. Grid on our output, grid width and height. Yeah, I think that's what we do. Our initial wave state. Let's do a small output grid of like, say, 20 by 20. I don't know how fast this is going to be. We'll use, it doesn't matter what number we use for the seed. And then we use our pattern results. Okay, and now, with our wave state, we should be able to run the wave. Final grid. Run wave with our initial wave state. And our function, which is going to be collapse wave. That's kind of jank, but fine. For now. So then we get a grid back. And we want to see that the grid is at least different than what we started with in the initial wave state that we generated. So if we get this grid, do we have an equal instance on it? We do. We're going to wave init wave state. Wave state grid. It's not equal. Final grid. That should be true. Okay. Yes, we still have to implement texture from list. So let's go do that quickly. Okay, so texture from list is list of A's. Size. We only support square textures, I guess. We need a size. Like it is the first parameter, so it's nice there. Texture A, like that. Booyah. Make sure I got my chat up. Okay, texture from list, no problem. Size. And the X's. So we're going to use our array constructor here. Following a similar pattern to make texture above. Right, we're going from 0 to 0 to size -1 by size -1. And we give X's. Okay, the problem is Okay, it doesn't know. That's just a type. Doesn't know what the type of these are, so I'm just apply that to int. Okay, cool. All right, we got an exception. Cool. No remaining patterns in that attempt. No remaining patterns. Got here in the check collapsed function. Oh, okay. We got some things to figure out. Okay, check collapsed. You only use it in may remove possibility. When we're constructing the cell after removing the possibility from it. Remove those, okay. All right, so in remove possibility here, we have maybe collapse. We check the collapse. Another reason why we might want to flip those out. Oof. Maybe collapsed. It turns out is partial. Sorry, check collapsed. Partial. Okay, so we've eliminated, if this code is correct, we've eliminated exact, from one cell, we've eliminated all patterns. We can trust exactly one. Let's just double check the implementation of that. Okay, let's do a quick little spot check here on the module. Oh, it's algorithm, sorry. Algorithm. Okay, so we have exactly one. Let's see, that takes a function a to bool. Which is we just use ID and the array. Okay. I'm going to import data.array. Well, we do list array, and we'll do list array 0 to 1, 3. So 4 elements. We'll do true, false, false, false. Okay, exactly 1 at index 0. Cool. False. Exactly none. We'll do exactly 1 at index 3. I think that's fine. Yeah. Okay. What do we call remove possibility here. Okay, let's do some debugging, some print style debugging. Do debug.tracesim, and we will show the, let's get the wave state. And then we'll get state again. After it's been changed. Just raise that one as well. That's probably going to spam us a lot here when we go to run this test. Once we get compile. Because this function gets called a lot. Oh, we don't have a show on wave state. Right. So we have to be a little bit more specific. We just want the grid. No, yeah, the grid. Yeah, I think that'll be fine. Gazoosh. Okay, I have to. See, yeah, it's spamming a ton here. Let's narrow down our test even smaller. There we go. Bam. Let's make the output texture just 10 by 10. Okay, still too much data. Okay. Let's see how. So this possibilities array has a bunch of cells that are still possible. I wonder if we can get into that case. Where is it? Do I have a search in this terminal? Okay, I don't know how to use this terminal that well because it's Windows and I don't use it a whole lot. So I'm going to copy this into a buffer and I'm just going to try and do a little analysis on here. Let's see if we can find which cell it is that we're eliminating all possibilities from. Turn Haskell mode on in this session here. And just slow it down a little bit, take it a moment. Maybe I shouldn't have. My Emacs is being crushed under the weight. Because it's in the background trying to fire up a GHCI process and load this code and stuff, probably. I can cancel it though, I think. Okay, it's coming back. Okay, there we go. That's an array with exactly one cell possibilities, so that shouldn't be triggering the branch. Not gonna go super well in this buffer. I'm gonna kill this. Or at the end. Pulse. Okay. False. Okay, that one is also false. There's one true in that one, so it's not that. That one's got one true in it as well. Just go cycling around here. Huh. Okay, actually that kind of makes sense. Okay, so we get to this branch of leftness on this array. It looks like this is the only one where we have false values in it. False, 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 false. 1 true, and then false, 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 false. Cell collapse. We picked the value 11 for this one. There's the one that's still true. That's the one we picked. At 1, 4, we got true, 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 true. Cell collapse, nothing. The only one with just. Yeah, it's the only one that's collapsed. Okay. So if that's the only one that's collapsed, that's mean we just got to collapse. Propagate collapse. Go to eliminate it. Oh, we check collapse. Collapse at. And collapse cell. Pattern index, we pick a pattern index from that cell, and then we return a new cell. Collapse cell possibilities. So just pattern index, so in that case we picked 11. The cell total weight and log total weights were set to 0 for that cell. We return the remove pattern for it as well. Calculate a new grid. The array is updated where cell index is the last cell. That's done. We have pattern stack removal pattern there. We'll modify the state with our new grid. Remaining cells and our pattern stack there. So collapse cell. Collapse cell possibilities. All right, take a pattern index, an array, update the array basically. Keep if matches picks, associations from the array list. This is what sets this one to true and the rest to false. Okay, we've got that. That goes well. We get to no remaining patterns and check collapsed. Oh, okay. So it's possible that here, when we go to the elimination step, this might be wrong. That might be where it is. Doo-doo-doo-doo-doo. Get rid of those others. Okay. Running a little out of time, so we might have to fix this test for next week. But let's see here what we get. Right, remaining patterns. Okay, so the array we got is input there. Just before we went to go check. We got false, 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 false. False, 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 false. Yeah, so that line is probably wrong. Right. Remove possibilities. Shouldn't be setting this pattern index to false. Alright, we only need the pattern index for... The logic here, what is it? I think that's the problem, because if we look at cell possibilities before, I think we will find that one of them was true. Yeah, 11 here is true. Okay? Yeah. False. Okay, so the assumption here then in remove yeah, okay. So the cell possibilities, the remaining possibility is the one we picked. And that's already been done for us by the time we get to remove possibility. So all remove possibility now is really useful for is updating the cell weights. I think if we get rid of this, we might get a little more... I'm not saying it's going to fix it, but... change that to cell possibilities. Or leave it remaining. We'll just comment out that part. Maybe collapse back in. Okay. Cool. Okay, that's definitely a thing we need to fix there. And then filter possibility. Interesting. So we got to that. All right. So we're gonna have to fix remove possibility or rename it. Leave that here. Rename or fix me. Seems we've already picked the remaining by collapsing before calling this. Okay, so I'm gonna leave the debug stuff in there for now because we're still just in progress, just learning code. And then we are getting to here. Ooh, which is interesting. All right. Well, we'll be off on our debugging adventure next week. I'm out of time this week, so I'm going to commit this. We're going to add run wave test. Doing a bug fix sweep. Not finished. Work in progress. Okay. So thanks again for tuning in, watching, and following along as I continue on this little Haskell journey with you. It's been sweet and fun. Hope you've enjoyed. All the code that you've seen tonight is up in this repository called Wave Function Collapse. I'm Agent Ultra on GitHub there and in most places. So you can check out the code there. It's on the GitHubs. If this is your first time tuning in, welcome. I hope you've enjoyed and had a good time. You can find me on the Fediverse on Mastodon. I'm on the types.pl server at Agent Ultra there as well. And that has the links to all my stuff. I'll paste that in chat for you. Right, so it's got my website, it's got my YouTube channel where I back up all my VODs from these streams to on my website and stuff. And if you follow along here or just make note of it, I often update about the stream and like when stuff I'm doing, working on, things like that, as well as other random things. And of course, if you're here on Twitch, you can follow. That'd be great. And then enable your notifications, and then you'll get notified when I go online. Otherwise, just make note that I do these streams usually on Tuesday evenings in the Eastern time zone. About once a week, about 10 after 8 p.m. in the evening. So, yeah, hope to see you next week. I think maybe we should try to find someone to raid, perhaps. And, yeah. Let's go. Who's online? Nobody I follow, but I like a lot of Final Fantasy content. So I play the 14s sometimes. Ooh. Oh, did I see John Romero's on? No. Oh, I just saw him. He's offline. Dang. Where are our... Our good categories? Software, come on. There we go. Good old search. Okay, let's see. Kook. Let's raid Kook. Jitspo. All right, cool. So thanks again for watching. Make sure to give Jitspo a like, and a thumbs up, and a follow. You know what I mean? Mail your monas be free, and your types always check. Let's go. All right, here we are. Take her easy out there.